Here's our second example. In this case, we have a teal car, which is moving. So I'm going to put a little T here to remind us this is the teal car. I'll use a capital T, and this is a gray car. And the teal car is moving along the track in this direction when it smacks into the gray car, and it's a completely inelastic collision. That means that they hit and they stick together. So these two cars are joined here after the collision, and they move off together. So this is very similar to the problem we did in lab. Okay, so let's write down what we know. We are going to have the mass of the teal car, which we happen to know is 0.360 kilograms. We get that from the problem. The gray car is going to have a mass, and it's a little less, 0.25 kilograms. We have the velocity of the teal car initial. That's how fast it's moving before the collision, and that is positive 0.55 meters per second, and it helps with the positive there. And it crashes into a stationary gray car. So the velocity of the gray car initial is 0. It's stationary. And then we're trying to find the final velocity of the joined pair. So this is where this problem is just slightly different. After the collision, these two cars are joined together. So we don't have to worry about separate velocities. We can just say the final velocity of the pair. And that's what we're looking for. Okay? So we're going to start with our big idea. And the big idea is that a force acting for some time causes the momentum to change. And if we look at these two cars as a system, there are no external forces. The teal car pushes on the gray car pushes back on the teal car, but there's no outside forces. And so this is 0. And that just means the change in momentum is 0. That tells us that the momentum at the end of the problem has got to be the same as the momentum at the beginning of the problem. So this is, again, what we call the conservation of momentum. And I want to see those two lines in your solutions. Okay, let's write out what this means. The initial momentum is the momentum before the collision, and so that's going to be the mass of the gray car times the velocity of the gray car initial plus the mass of the teal car times the velocity of the teal car initial. That's going to be initial momentum. And here we can kind of use an idea. If these two are joined together, we don't need to calculate their momentum separately. The final momentum will be the mass of this car, which is going to be the mass of the teal car plus the mass of the gray car, because they're joined. So that's the mass of this thing times their final velocity. That's the final momentum. Okay? So that's the slight difference between this problem and the previous problem. When two things are joined together, you can find their momentum by taking their combined mass times their velocity. Okay? All right, now once we've written out the momentum statement, we can figure out what we're going to do. In this case, we are going to solve for the final velocity. We want to know how fast these cars are going after the collision. So we're going to solve for this. Before we start solving for it, though, let's do anything that's 0. We know the velocity of the green car initial was 0. So if the velocity of the green car initial is 0, this entire term disappears. And so, to find the velocity final, we can divide both sides by the teal car plus the gray car mass. So divide this side by it, that'll cancel. And divide this side by it. So this is the mass of the teal car plus the mass of the gray car. And so we end up with an expression, the final velocity of the pair joined together is going to be the mass of the teal car times the velocity of the teal car initial, all divided by the combined mass, which is the mass of the teal car plus the mass of the gray car. Okay? So there's an algebraic solution. We can go ahead and plug in our numbers. And once we plug in our numbers, we can evaluate it, and we get 0.325 meters per second. That is the final velocity of the combined pair. So what we did was we used the conservation of momentum, the final momentum equals the initial momentum, to build ourselves an equation, which we can then solve. So this is what we call a principle. We use it to build an equation, we solve our equation. Okay? So on the homework, be careful. Don't just try to grab this solution and plug in your numbers. You've got to start from here, write out what it means, write out what that means, cancel things that are zero to get your solution. Okay, so I want to see that work on each problem. Okay, so that was example number 2.